I'm James Haliday, or you might know me on Twitter, GitHub, etc. as Substack. I've written a lot of modules, and I'm going to talk about some of those. But, I guess I should say I'm co-founder of a startup called Browserling, and we make a product called Browserling and a product called Testling. They let you test your websites in all the browsers. They're super great. Check them out. Anyways, so today or tonight, I'm going to be talking about a couple of modules that help you build federated infrastructure. That's the sort of architecture and system where you can basically spin up a lot of processes and have them all talk to each other. And those processes can be on the same machine or different machines. It's more of the power of that approach is more about keeping sane and organizing your code in a way that's not going to just explode in complexity like you might encounter if you're just building a giant monolithic app, like with crazy state everywhere. But splitting everything out into processes sort of makes it so that you can't cheat and accidentally introduce some state over there that's sort of implicit, or like abuse the file system, so you're like using that as an ad hoc data store, all this kind of stuff. So anyways, I think the best way to demonstrate that is to start show you guys how to build an app with some of these tools that I've been working on. So the first one of these is called dnode, and you can find that on my GitHub. This is a project that I've had out for a long time, and it's seen a lot of iterations, and we've put this library to use in our own software stack at my company for a lot of stuff, and a bunch of other people have too. So it's pretty stable by this point. But basically what dnode lets you do is you can write, you write a server, and you write like another server maybe, but it's also sort of a client, right? It can connect to your other service. So for instance, maybe you have a web app, right? And you need to do authentication. You might go down the route where you want to do authentication by, say, just building that, putting something in your lib folder, organizing it, but that can sort of get out of hand. And it gets especially annoying when you want to start splitting everything out into multiple processes to do load balancing, or maybe you just have another product or another service that needs to interact with your auth system. You don't want to write the code again, and it can just get really complicated. But or you can just spin up a separate service. So here, let's just create a really simple web server. We'll call it web.js. So very HTTP equals require HTTP, et cetera, HTTP.create server. You know the drill. And then just the simplest possible thing that could possibly work. So we'll listen on process.argv. Just the first arg is the port, basically. And res.end, beep boop. Actually, why don't we write out a message just for later? That'll be interesting. So, okay, so basically, we run this server. Whoops, bad argument. Oh no, what did I do wrong? Quick audience. Oh, here's what. That's a string. Strings. Okay. Oh, right. It's because I didn't even tell it what. So let's say 8085. Okay, cool. And we'll tell it a message. Hello. And localhost 8085. Sweet. So it did some stuff for us. Super simple web server. Okay. But suppose now we want to build a really ghetto auth system that's just really silly, but you can use your imagination to fill in the gaps of actually contacting a real database or whatever. So we'll call that auth.js, right? And we can make a dnode server for that. So require dnode. Dnode takes a constructor thingy. So you get the remote and the connection object, and we'll listen on process.argv because that'll be handy for something later. Dnode is actually smart about strings, so. And we need an auth function, right? So auth functions usually take what, a username and a password, and we'll just give it a callback to tell it what result, whether it was okay or not. So this .auth equals function, user pass, callback, right? Super. So, because I said this is a really ghetto auth system, we'll just hardcode our username, our database right in there. So that'll be the first user, name of foo, and like I'll just have it. That's the password. Why not? And there's only one of them, so whatever. Okay, so var p equals user's user. If p equals pass, and we'll just do an empty callback because we don't really care about data right now. And else cb access denied. Okay, cool. So if we spin that up on say 80 or yeah 8090, why not? Then we can just test real quick that it works by just on the REPL here, connecting to it. So it's on 8090, and I'll just console.dir the remote object. Oh, and then there's a lot of spam because it's like the return value. Okay, cool. So that's the function that we just defined. The awesome thing about dnode is when you just define functions, they can just take callbacks, and it just is magical, and I'll just wave my hands like I promised Charlie that I would about that. So we can call this remote function, actually. So we'll do remote.auth, username, password, and then like the error callback, right? Console.dir error. Okay, so it gave us null. And that's great, because that is a valid username password combination, right? What if we give an invalid password and our username? Awesome, access denied. So now we've got a really, really, really basic, awful auth system that you should never use, except maybe to shim out a real one. So that's great. But now we can make our web server actually connect to this auth service. So if we go back to our web, and I can just like copy paste this basically from the REPL, right? That's how I usually develop stuff, basically. And I'll just pretty that up a little bit, but I mean, and so this time we'll make like the default route the same as it was before, but like, oh, actually I got that backwards. That should be the default route, and we'll make a special route for authenticating. So we'll call it login, how about? Now, here's the cool thing. So first, I'll show you guys how this works with dnode right now. And then we can retrofit this example to use upnode, which is another piece of software that's like an awesome wrapper around dnode that I've been working on a lot lately. So because you call dnode in a callback, you have to like wrap your whole server, which is a little bit annoying, right? But that's cool, because like Vim has this sweet like shift width thing that like indents a whole block, so it's great. So we http.createServer in our dnode connection, right? And we rec.url is login, cool, and remote.auth. And that takes an error back, so callback with error in it. And instead of console.log, we can do a res.end, how about, with just the error value. Or actually, if there's an error, then it should print. Otherwise, it should print, OK. Sweet. So if I run this, I have to, of course, be running the auth server first, but it's already running. So if I run this, wait, except I didn't. Yeah, I should specify those as parameters. So what's a good way to do that? Let's see. So I'll use the query string module to just parse that real quick. And we can do params equals rec.url dot, oh, geez. Yeah. but we got to split on the like question mark daily first. So, and then qs.parse. Right? Does that look good? That might work. Who knows? So param.user and param.pass. And the rest should just be OK. So we'll run that. And that's running on localhost 8085. So like before, we still get that input. But if we do, and I have to quote this because it has like ampersands in it, login, user equals foo, and pass equals bar. Whoops. OK, login. Oh, this is super silly. OK, sweet. So we've got a login route now, whatever. And I did it wrong, because, OK. So, What's, oh, there's too many slashes. OK, but now, OK, sweet. So we just built a federated auth system that totally sucks, but it's awesome because it demonstrates my point about how to do this with dnode. Now, as I was saying earlier, if I'll just kill that, like having to indent everything is kind of stupid, right? And it's especially bad if you want to like not fire up your auth server always before your web server, or like if your auth server craps out and dies, or your web server does, and like negotiating all that is really awful. So upnode helps with that. So instead of dnode, we can just require upnode here, and then I just have to make a quick change to the server. So you can still, like create a regular dnode server, but you have to do, well, you don't have to, but it makes it work a lot better if you do server.use upnode.ping. And that just like turns on a magic pinger thing that's awesome. So that's running. And instead of this awful dnode.connect stuff, we can do var up equals upnode.connect, and just like get rid of that awful callback noise and like put it flush with the margin again. So that's super sweet. And then instead of remote.auth, we can call up. Now the cool thing about this is that if the upnode server is like already associated, then it just fires right away. But if it's not, if it's like not connected to the auth server, then the connection and the request will actually buffer until it is connected. So it's always trying to do reconnects. It's a bit like something like 0MQ or like message queuing systems, but it's really kind of just a really, really lightweight version of that. So cool, let's try and run this beast now. Sweet, no syntax errors, that's a good sign. And if we try to run that example again, holy crap, it works, first time. And just so I'm not deluding myself, I'll try like an invalid password. Hey, that works too. Awesome, so we just built this crazy federated system that's using upnode, and it was super sweet. So what's next? It's sort of awful if you start building these federated systems to like spin off your processes on a lot of servers and like run like basically 9 screen sessions or 9 tmux sessions and like, you know, log into all your boxes with some awful SSH command or whatever. So let's not do that. Let's use something a little more sophisticated. So this is actually what I finally finished this up tonight. About 10 minutes ago, I npm published it. So might be a little bit rocky, but the project is called Fleet, and you can find that on my GitHub profile too. Basically, if I can just kill these for a moment and navigate to a temp directory. Actually, first of all, I'll make a new Git project right here and just check our little server programs into Git and check in node modules, why not? That might work, who knows? Beep. OK, whatever. So cool, we have this Git project now. Now we can start setting up some worker nodes with Fleet. So I'll just go into temp to sort of simulate what it's like to be on just a completely separate system that doesn't know anything about your Git or any of your config. So the first thing you do when you set up a new Fleet server is you type Fleet hub, and you give it a port to listen on. So like 7000 is a good one, and like a secret passphrase. So that'll be just like beep boop. And cool. So this Fleet server is now listening. The crazy thing is this Fleet server actually has a Git HTTP server in it. So you can Git push to this, and it's a little bit magical, but in a good way, I hope. So now we have a hub, but we need some like worker drones who are actually going to run these processes, and those can be on like whatever system you want. So I'll just navigate to temp. Oh, actually, I should, instead of doing that, I should make like a new directory, because yeah, otherwise it gets just complicated. So I'll make a directory hub and have that listen there, because this actually creates a couple of directories in your current directory if you don't give it one. Anyways, so I'll make just a empty directory called drone0, and now we can run fleet drone, and you give it the hub location. So this is on localhost port 7000 and secret, which is beep boop. And that's all you have to do. So it said connected to the hub. Great. Now, this is the super amazing awesomeness part. We can set up a fleet remote. So fleet remote is a lot like Git remote. It lets you like specify a place that you can push your deployments to. So we can do fleet remote, add, and then I'll call it default, because that's, if you don't give it a name, that's where it pushes to by default. Hub equals localhost 7000, secret equals beep boop. Yes, correct. OK, sweet. So if I do fleet remote ls, then that's the config. So this is super great, because now we don't have to ever like type in that hub and secret stuff, because it created a fleet.json file in the Git root, so it like traverses back up until it finds a .git, exactly like how Git remote works with its own like .git. Anyways.
Didn't capture your secret with 2 dashes?
Oh, yes, correct. Good spotting it. Yes, it does. That was silly. Good eye, because now it's in the JSON file. Awesome. OK, so we have the fleet remote set up. So now we can do a fleet deploy. And if I just type that, it should, because we already set up the remote, just, oh, yes. So what that did is it actually contacted the hub. And because the drone was connected to the hub, it did a git push to the hub. And then the hub did, like, instructed the drones to pull from it. So basically, right now, we have, crap. We have, if I just like quickly push d dot and go to the fleet directory and go to like drone0 to check out what's going on, it made a new directory in the deploy directory. So that's just like the project name dot the commit hash. Every time you do a fleet deploy, it puts it in a separate, clean, new directory, which is super great if you want to like just run a lot of variants of the same process at all times. So you can start doing awesome things with your HTTP router to like dynamically route between different versions of your app without them having like conflicts and without like bringing your whole site down. You could like spin up everything and just keep it up all the time and like have old versions around so you can like automatically roll back or do incremental deployments, all kinds of craziness that this approach entails. And so if we just like poke around in there, sweet, there's our, like all of our code on our drone. Awesome, all over the network. So we deployed it, but a deploy doesn't actually launch any processes. If we do a fleet PS, that tells us the process list. So that's the drone ID, and there aren't any processes. But we can spawn one. So if I do fleet spawn, and the dash dash is like with getopt, how you can sort of turn off processing. So if we want more switches, it's not going to be picked up by fleet itself. But so if we just, let's see, we have our node, or our web and our auth server. So if we just spin up our web server, on, I don't think, okay, whoops. Oh, I should leave that running. Oh, this is the other awesome thing. Because everything is running up node, you basically just kill anything and bring it up again, and it all just reconnects awesomely. So you don't even have to worry about like pending requests because they all get buffered. So we do a fleet spawn node web.js and spin up that service on 8085. OK, cool. And if I do fleet ps, it tells me that the first drone has this process running, and it even tells me like what command I issued. Now, if we want our second process, I'll call that auth.js, and I think that those are hard-coded, so that's going to be a little bit difficult. Well, yeah, it's hard-coded to 8090, so we better spin it up there. But so we'll spin up that, and now fleet ps. Sweet. So if I curl to localhost 8085, awesome, our app is still running, and like I bet our login stuff even still works, which is super cool. Login, user equals foo, pass equals wrong, access denied. Awesome. So we just use fleet to deploy to like crazy worker drone infrastructure. Awesome. But suppose we want to like make some commits now. So maybe we don't like that that is hard-coded, because I don't really like that. So process.argv4. And yeah, OK. So now if we spawn up a new version of the web server, the first arg is the port that it listens on, so 8086. And then the second arg is like a silly message. Beepity. And then the third arg, just because this is a silly app that it's just a demonstration, is the port of the auth server. So that would be 8090. And we do a fleet ps. Sweet. So there's all three of our processes in our whole crazy cluster. And we can curl to localhost 8085 and 8086. But look, the message is different between those two versions. So we're actually running two separate versions of things at the same time of our whole infrastructure. And we're like, we have two variants of our web app, but they both connect to the same auth server. So the next part of the puzzle that I'm working on right now, I mean, Fleet, I just got that working today. The next part that I got done earlier is called Seaport. So this basically lets you manage all of those, if you have infrastructure like Fleet, managing like where all the ports are of everything can be really difficult to do by hand. So Seaport makes that entirely automatic. You basically set up a Seaport hub by doing just Seaport hub. It's pretty similar to how Fleet works. And then in your code, I'll just make that super big. Bigger. You set up a service, or you set up a server. There are also some command line tools, so you can basically not even use Node. Whatever infrastructure you have in place, you can just like issue a Seaport command. But the basic idea is you set up a server, right, like an HTTP server or whatever, and then you tell Seaport that, hey, I have a server. It's called web. And this is the really crazy part. I actually got this idea talking to Paul Querno like last month, but it's working super well in practice. You can give it a semver. Semvers are like how in NPM you can have like 1.2.x or like a tilde and like 0.3.3 or something, and it like magically sort of figures out what versions are acceptable. Seaport lets you do that for processes in your infrastructure. So you can have processes. So you provide a version service to your whole cluster, and that gives you a port. And then you can request a port with a semver, so 1.2.x in this case. And that gives you like the host and the port name of that piece of infrastructure, which is super great because if you're like shimming out new variants of processes in your systems, then you can just let Seaport sort of figure out how all that should work for you, so you don't have to keep it all in your head. And the next part that I'm going to be exploring a lot more is tying seaport into HTTP routers, because then you can basically like automatically point your HTTP router at different versions of your software stack. So like giant companies like Facebook are already doing this, and Google are already doing this for incremental deploys, for like bucketing their users into different cohorts, for doing A/B testing, and all kinds of craziness. So that's basically all the pieces that I wanted to talk about tonight for federated infrastructure. So thanks. And if there are any questions, I guess we could do questions, maybe, briefly. OK, sure. Questions, go ahead. Or not. But npm install -g fleet, because it's super great.
Sweet. Cool. Okay. Thanks.
OK.
Awesome.